once it starts recording. And there we go. Okay, good morning. Good to see you. A couple things I wanted to mention before we jump into what we're going to work on today. On today's announcement, a couple things you will want to have open. Again, right underneath the links for today's Google Meets is a link for today's work, which is, I'm calling it homework 4.2 because I'd love to just kind of see your work, submit what you've got so far. Once we get it done, I expect us to just do it all today while you're here, so nothing you have to do after class. A couple rows down from there are some links to unit circles, blank ones, and complete ones, which is always good. The other thing that I wanted to point out, I don't know how much you know about it, but every year Douglas County School District has something called the Apple Awards. And it's a chance for students and parents and other teachers to nominate the teachers or staff members that they think are doing the best job at each one of the schools in Douglas County. So whether it's a high school, middle school, or elementary school. It's something that really doesn't exist without your input. I mean, you guys have the best idea of who's kind of standing out. And this is not a plug for me, for you to nominate me. It's quite the opposite. I want you to just kind of think about anybody that you have this year, whether it's a teacher or a counselor or an administrator or a secretary or somebody that you think really has gone above and beyond. And if you feel like they deserve to be recognized, there's a link there that says the PHS Apple Award nominations. Okay, it's something that really doesn't exist without your input. So you guys know who's doing the best job. Again, if you think it's me, great, but I don't expect that, not even a little bit. So this is not some sort of shameless plug for you to nominate me. It really just is a heads up that it's happening, and that if you don't vote, who will, right? If you don't nominate people, who's going to? So if you feel like somebody has stood out to you so far this year, again, teachers or staff members all around the building, click on that link and write up a quick little something about that person, and whoever it may be. Would love to read that. So if you feel like somebody has stood out, just go ahead and click that link at any point before December 20th. Okay, the nominations close basically at the end of next week. Okay, so that's there for you. I will keep kind of linking that to announcements, so that if you do get inspired to write a little quick paragraph about a teacher or a counselor or somebody that's doing an exceptional job, especially now during this hybrid and now remote learning, it's definitely a different adventure for us to have to deal with this. So cool. And then at the very, very bottom, I put this on yesterday's and I got a few responses, but I never talked about it. If there's some feedback that you think would work really well for me to know about how you're doing or about how the class is going so far, and especially now that we're fully remote, I'd love to hear about it. It could be anonymous. It could be, you could write your name. That's cool too. No pressure. I just wanted to give you a space to give me some feedback. If you want to put your name on it, great. If you want it to be anonymous, that's good too, right? The good, the bad, and the ugly, right? Whatever's happening. I just want to kind of refine my teaching and be a little bit better for you. So, okay, let's jump in. And I wanted to start with stuff from you. So there's the link there for that homework 4.2, which will take you to the assignment in Canvas, which you can then click and open from there, that have these 10 problems on there. And I would love to take just these first 5 or 10 minutes and give you some time to just work, to try these out from yesterday and make sure that we take the stuff that was kind of stuck in your short-term memory from yesterday and we start to build it into more of a long-term kind of thing. Because basically after this week, and maybe we'll meet up during next week's final class period, obviously not for a final, we did that already, for a little optional extra credit kind of thing, where I don't do anything new, of course, so you don't have to come, but And then 2 weeks goes by. I want to make sure that this stuff starts to work its way into your long-term memory a little bit. So open up that homework 4.2, today's work. And then part 1 right there is just a refresher from yesterday on how to evaluate all of these trig ratios wherever we happen to be in the unit circle, okay? And it's, 840, I'll call it like 850. I'll pause and come back around then. I'll start filling out some solutions so you can check as you go, but I want to give you some kind of quiet time to just work and see what you remember. And you can look back at the stuff you did yesterday and have the unit circle out and have those trig ratios out so you know what's going on, so you know which ones are reciprocals for which, and just give you a chance to try this out and see what you can do. Okay, and then we'll just do one other new thing today, and then we'll go. Okay, and we'll be back again tomorrow. Okay? So a little time to work. I'll give you a little peace and quiet, and ask questions. Right? If you get stuck on something, you're not sure what to do, give me a shout, let me know. I'll start putting some work up here in about a minute, so that you can see how it's going. Okay? And I'm really, like we did yesterday, it's all the same kind of stuff. So I'll just jump right in. I'm not even going to wait. So 1 through 10, part 1. another couple minutes if you need it. Check my work as you go. I'm gonna take a picture of this so I can post it later, so we can go back and look at it in case we need it. Okay, how are we doing? Does anybody need any more time? You all good? How'd you do? Did okay? I really can't make this any trickier than this within the unit circle, right? If we stay between 0 and 2 pi or 0 and 360, and we're looking at, I mean, we got all 6 of them up here, so we're all good. We'll build more in January, what we can do with stuff like this, because I can add these together. You know, I could say tangent of 3 pi over 4 plus cotangent of 7 pi over 6. We can put those into one expression. Or I can say, let's take sine of pi over 4 squared. You know, and we can square the results from doing sine of pi over 4 and getting more interesting kind of results from there. And so we'll definitely do that in January. We'll deal with adding and subtracting ratios. We'll do adding and subtracting angles. You know, what's sine of pi over 3 plus 6 pi over 7 or something like that, and see what happens. So lots of other things that we can do with this, but if you know how to do that, then you can do everything else that comes with kind of evaluating trig ratios. Okay, here's the new thing to do. Coming over here. Try to center up a little bit more. Okay, might be a little small. Sorry about that. But here's what's going to happen next, right? Or here's what's happened so far. When we deal with just kind of regular, basic evaluating trig ratios, they give us an angle, and we can find the ratio, right? As long as you tell me which ratio you want, right? Do you want the sine ratio, the tangent ratio, the cosecant ratio, whatever, okay? But what if it went the other way? What if they were to give us the ratio? They say, okay, sine of something is 1/2, or 2/3, or radical 3 over 2, or 0, or undefined, or something like that. If they were giving us the ratio, and I want to hear from you, so unmute yourself if you have an idea. What do you think? And they tell us which ratio, right? They say, here's sine, here's cosine, whatever it is. And they say, it's 1/2, it's radical 2 over 2, it's -1, it's undefined, it's 0, whatever it is. What do you think we could find by doing that? If you give me the ratio.
Angle.
Nice. We can find, and maybe more than one. We can find potentially angles, more than one, that get that job done for us, that get us to that ratio, right? And it's just kind of reversing everything, right? And so here's the thing about the way that trig works, which I know is going to be a little bit different. When we're given an angle and we find a ratio, like that's input and output, right? That is, you know, x and f of x, okay? Of course, we don't call it x, we call it theta, right? And so now we've got this f of theta. So I'm not going to use x, I'm going to use theta, and I'm going to use f of theta. And now we're going the other way, right? We're doing the opposite. We're given a ratio, and we're able to find angles. We can do inverse trig, okay? Which you might have seen before. Okay. And if not, that's cool too. Go back to the homework, the 4.2 write-up. And check out part 2. I want to do these together. Okay. Part 2, inverse trig. Let's go backwards. And you can see this is why I go to sleep at midnight, because I spend time writing sentences backwards just to entertain myself and maybe even one or two of you guys while I do it. Okay. So here's what it looks like. Okay. Inverse sine. So sine and what looks like to the power of -1. Again, you remember inverse notation. It's not really to the power of -1 because that means reciprocal, right? It's just a symbol that means do the inverse of that. And so what's going to happen is that on the inside here is not an angle like it was with regular trig, right? Sine of 30 degrees, sine of pi over 4, cosine of 7 pi, whatever. That's them giving us an angle, and we find the ratio. Now what's going to happen is on the inside here, right? They're switching x and y, they're switching x and f of x, they're switching theta and f of theta. What's going to happen in here is they're going to give us the ratio, and our job is to figure out an angle or more that gets that job done. And normally what they ask us to do is look between 0 and we include it, and 2 pi, but we don't, because that would just be repetitive. To say that 0 and 2 pi have a certain ratio, of course they do. They're at the same spot. So we're going to include 0. So 0 could be an answer, but we're not going to include 2 pi as a possible answer because that's kind of repetitive, okay? And so what I want to do is I want to think back to unit circle. And this is all unit circle stuff for now. We'll get to non-unit circle stuff soon. I want to look at angles in the unit circle whose sine value is 1/2. I want to look at that picture of that circle, and I want to find, okay, so sine is y. I want to find the coordinates along the unit circle whose y value is 1/2. And maybe there's 1, maybe there's 2, maybe there's 4, maybe there's 0. Who knows, right? We just have to be able to look, okay? And so that's what I want you to do. I want to do these 6 together, okay? But I want you to help me. Look at your unit circle, find a y value, because it's sine, so that's why I'm saying y. That's 1/2. And give me one of them.
Pi over 6.
Pi over 6. Good. Okay. Is there another spot on the unit circle whose sine value is also 1/2?
5 pi over 6.
Good. Okay. And there are 2, and you can write them as a set if you want. You don't have to. There are actually 2 angle measures that do this. Okay. Pi over 6 gives me a sine of 1/2, and 5 pi over 6 gives me a sine. That's 1/2 because they're directly across from each other, right? If you look at the unit circle and you've got 2 points that are directly across from each other, their y values are just going to be the same, right? And so I should be able to find, in this case, those 2 possibilities. Okay. All right. Let's do another one. And don't read this as cosine to the -1, right? Read this as inverse cosine of -1/2. Right? See if you can find 1 spot, 2 spots, 3 spots, 4 spots, 0 spots, whatever, whose cosine, so whose x value is -1/2. a good order to look in is to follow around. Oh, that's a terrible circle, but I'm just going to keep going. We want to write them down in the order that we would run into them by opening up an angle. Okay, so you want to find the first one by saying, okay, I'm going to look in the first quadrant, then second, then third, then fourth. Is there a spot whose x value is exactly -1/2?
2 pi over 3.
Is there another one?
Or pi over 3.
There you go. Okay. 2 possibilities for both of those spots. Good. Okay. Inverse sine, number 3, of negative radical 2 over 2. Are you looking for x here, or are you looking for y?
Y.
Yeah, sine, right? Sine's the y value. So look at your unit circle. Find 1, 2, or 0, or 3, or 4, or 5, or 6, however many you can, whose y value is negative radical 2 over 2.
5 pi over 4.
5 pi over 4. Is there another one?
7 pi over 4.
Directly across, right? Now, the thing about the cosine ones, they were right on top of each other, right? If you went to 2 pi over 3, you're kind of over here, 120, right? And then if you go straight down from there, right, straight down, your x values aren't going to change because you're not moving left to right. You go straight down from that spot. That's why we run into 4 pi over 3 right there, okay? So if you're looking for inverse sine, you're really looking for points that are right across from each other. If you're looking for inverse cosine, you're looking for points that are right on top of each other, right? Because these have the same y values if you're horizontal. These have the same x values if you're vertical. Okay, cool. 4, 5, and 6 are just a little bit different, so I just wanted to throw this out at us, okay? Inverse cosine of 1. And again, if they're writing inverse cosine, I'm given a ratio. Now I know 1 is not necessarily a ratio, but it is, right? It is a number that can be written as a fraction. So, but really, I want to think mostly about the fact that this is inverse cosine. And if it's inverse cosine, then all I really care about is finding an angle or a set of angles, right? Whose x value is 1. Where on the unit circle is x equal to 1? Within this interval, including 0, all the way up to, but not including 2 pi. What angle gives you an x value of 1? Nice. And we're gonna write 0 and not the 2 pi because that's the same thing, right? We're just gonna put the 1.
0.
And so when you end up at quadrantal spots, there's a really good possibility. Now, not necessarily, it is possible that we can just find a single angle that does that. Now, if I asked you for the cosine, and this is just kind of in between, if I asked you for like the cosine of 0, well, pi over 2 would do that, and so would 3 pi over 2, right? So it's not necessarily because you ended up on an axis somewhere because you're looking for 0 or 1 for sine or cosine that you're only going to have one answer. It depends on what you've got. But just be okay that we might only find one angle that gets that job done, okay? And here's the thing. You've got inverse sine, inverse cosine, and inverse tangent buttons on your calculator, okay? Cosine, sine, and tangent are right, just kind of regular buttons. Second cosine, you see that cosine to the -1, that's inverse cosine, right? Inverse sine, inverse tangent, they're all there. The problem is they're only ever going to give you one possibility, okay? And what's going to happen, this is our mindset. I'm gonna open up a positive angle this way and just see what I run into. I'm gonna take one full trip around the circle. What your calculator does, which is good in some ways, but a little frustrating at others, your calculator actually does two things at the same time when you press inverse, okay? When you press inverse cosine of something, or inverse sine, or inverse tangent, here's what the calculator is actually doing. It's going to open up a positive angle and simultaneously open up a negative angle, and it's going to search for the first solution it can find, okay? And so if you typed in something like inverse sine of 1/2, it's going to get you to 30 degrees right away, right? It's going to drop 30 degrees on you, or pi over 6, depending on which mode you're in. When you're doing inverse sine, I highly suggest that you hang out in degrees, because it will give you 30, rather than you being in radians and it's spitting out some fraction that means pi over 6, right? It's going to be a little bit more than like 1/2. Because the other angle that it would have to find would be 5 pi over 6, and it would take forever. It would take a full, more than a half trip around the circle just to get to that one over there, okay? So don't rely too much on your calculator when it comes to inverse trig. Regular trig is good because we've got all these nice answers that we can find. The decimal approximations for some of those irrational ones can be a little tricky, but just know you're only ever going to get one answer when you type in the calculator, but we need to know that there could be two or more. And you'll see as we get to like sine squared, we could have 4 answers, or cosine squared, we could have 4 answers. Okay. So there we go. Number 4, just 0. Okay. Number 5 says the inverse cosine of 3.5. Is there on a circle whose radius is 1, is there ever going to be a time where we could open up an angle and the x value of that point could ever be 3.5? No. Number we've got is 1. The smallest, the number furthest to the left that's possible would just be -1.
No.
Okay, and so this is undefined, right? The issue that we run into with these functions is that I could drop in whatever angle I want and get an answer back, but I can't do that in the opposite direction, right? I can't necessarily find any x value I want because of the way that cosine is restricted in the answers that we get, right? We're only ever going to get answers between -1 and +1, and that's the same for sine as well, right? Just regular cosine, regular sine. We're not looking at the functions themselves yet and messing with amplitudes and whatnot. But what we've got for sine and cosine, so sine of theta and cosine of theta, okay, is that their domain is infinite, right? That's going to be all real numbers, right? So you've got that fancy looking R right there. That just means negative infinity to infinity. But their range is between -1 and 1. And those are the only possibilities that we've got, okay? And now when we deal with inverse trig, these switch, right? So your range goes from -1 to 1, really becomes your domain, and vice versa. So I can't drop in a number like 3.5 because it doesn't fit, okay? And that's okay. That's the kind of stuff that's going to happen. We just want to be comfortable knowing that we've got no restrictions for sine and cosine for what numbers we plug in. But with inverse sine, inverse cosine, we do have some restrictions. We can only really be between -1 and 1 if we want to get an answer back. Okay. All right. Last one, a little challenge here. Inverse tangent of 1. And I want to do this one with you. Okay, so think about it. inverse tangent. Well, all right, so sine is y, cosine's x. Those aren't too bad because all I have to do is go look for them, right? I've got a unit circle sitting in front of me and I just find those spots that work. When we get into anything else, right, we have to start using x or y, or in this case, remember tangent is both. Tangent is the ratio y over x. And so what we're looking for when they ask us this kind of question, they're trying to find an angle, right? That's what we're always trying to find with inverse trig, trying to find an angle whose tangent is 1. Well, if the tangent of an angle is 1, then the ratio of y over x is equal to 1. Well, if I've got some fraction and the answer is 1, all right, so you've got some fractions set up and the result from that division is exactly 1. What do you know about the relationship between the numerator, whatever it is, and the denominator if you're dividing them and you get 1 back?
They're the same number.
Gotta be the same. So what we need to do is we need to, when looking at inverse tangent and they give us a ratio, an answer of 1, we're trying to work backwards to an angle. We're trying to find angles whose x value and y value are the same. So see if you can do it. Open up an angle. Let's go positive first. We'll just kind of make our way around so that we list them in a nice order. Is there a spot on the unit circle whose x value and y value are the same?
Pi over 4.
Perfect. Is there another one?
Five pi over 4.
Good. Okay. Right here, right at 45 degrees, because we know that those are radical 2 over 2's, right? And straight across there at negative radical 2 over 2, comma, negative radical 2 over 2. Good. Okay. So if we want it to be 1, we want them to be exactly the same, and that's what those two values are going to do. Okay. Now, again, you can rely on the calculator a little bit to help you out with stuff like this. You just want to make sure that whatever you do, you're doing it, I think, when we're dealing with inverse trig, that you do it in degrees, which I know might seem a little counterintuitive because we've done a lot of things with radians and radians only. I just want to show you what I see on my side of the calculator when I do it. And then we'll be ready to go just about. Okay, so in mode. Okay, so next to the second button, there's a mode button. And for me, it's right here between radians and degrees. And that makes a really big difference when I start typing things in, right? If you ask me to do sine of 30 and I'm in radians, that's 30 radians. That's not 30 degrees, right? I would have to type in something like sine of pi over 6 if I wanted to get that nice 1/2. Okay, so be really careful what mode you're in. And because I'm in radians, if I did something like inverse sine of 1/2, it's giving me this kind of nasty looking result. And I can't recognize that necessarily as being pi over 6. I just don't see that. And I don't really want to memorize all of those weird decimals that go with it. I would much rather, when dealing with inverse sine, be in degrees so that I get a nice answer like 30 degrees. Okay, but again, it's only ever going to give me the first possibility, right? I know that the sine of 150 degrees is also 1/2, and I know that that's the y value at that spot, but the calculator is never going to give me that solution. Okay. The things we want to just kind of be careful of, remember that the calculator is going to open up angles in both directions, a positive one and a negative one. And if it opens up those two angles, right, and we're looking for, and I just have that example up there, the inverse sine of negative 1/2. I know it might be a little tough to see, so I'm just going to bring this a whole bunch closer so it's big, right? It's going to open up that angle that way and that angle that way to try to give us what angle has a sine of -1/2. And look what we get, right? We get -30 degrees right here, okay? Because that angle is found first before we ever get over there to 210 degrees, okay? And so it can be a little bit tricky. So I just wanted to make sure that I talked you through that a little bit. Okay, last 10 minutes, let's try it out. We've got a part 3 hidden right here. I think my sneakiness is really not all that sneaky anymore if you start to know that it's coming. But it's there. There's part 3. That's yours. Okay, I want you to try those. Okay, so go back to that homework. I will stop sharing my screen so I can put up some answers here in a second. And try these 8. Okay, looking for spots along the unit circle when it's just sine and cosine. Remembering that you could have one answer, you might have 2 or none if we get ourselves outside of the possibilities. And then number 14 there will be a nice little challenge for you. Okay, and once you're done, just submit that work up on Canvas to homework 4.2. And you'll be good to go. And we'll come back tomorrow just for one last little new lesson. Something to kind of wrap things up a little bit here in the first half of chapter 4. I'm bouncing around a little bit. Really, we've gotten ourselves basically through 4.1 and we're getting ourselves into 4.4. I'm jumping around a little bit to do that. It just kind of flows nicely for me to do it that way. So I'm going to come over here and start jotting some answers down. I'm going to take pictures of the board so I can put these up on Canvas to help you out in case you need them. Let me add one last little piece over here. One last thing I wanted to think about adding to your notes. If you wrote down this sine and cosine have a domain and range of this and that, might be helpful to have a spot for inverse sine and inverse cosine, where their domain and range just switch. Okay, the domain goes from -1 to 1, and their range, you will see. We could really get any angle back we want. Now, normally what we'll do is we will restrict our answers to a nice spot. So I'm going to put a little asterisk next to that R because we will restrict the range so that we're not getting a bunch of repetitive answers. Like 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, and so on. Okay, so a little asterisk next to this. It is possible to get a whole long list of answers. But to save us a whole bunch of trouble, a lot of times we will restrict that range when the time comes to do that. So you may have done that last year. I don't know if you did any trig graphing last year. I think you did sine and cosine with those trigonometric waves, those sinusoids. I don't know if you did tangent graphs. My guess is you haven't done any inverse graph, the graph of the inverse of sine, the inverse of cosine. So that's just a little heads up. That will happen when we do that. When we graph the wave of inverse sine, it would go like this. It would be kind of this like snaking wave that goes up and down. But we will restrict it so it's a function, so that it's not going over and over and over onto itself because we have so many different answers. Okay, 7 through 14, and then we are good to go. And then you are the 2. Getting this close on. I'm getting better at this timing stuff, trying to get you guys out of here. Okay, inverse cosine. Load up. Negative radical 2 root 2. Hopefully 7 is not too high. Inverse cosine of 0. And then a nice little challenge there for number 14, the inverse tangent of negative 1. We did 1 last time. Use that mindset. Okay. 2, so that is going to be pi over 6 and 5 pi over 6. No, sorry. 11. You can see I'm using radians for all of my answers. This is just a good habit to get into. Degrees are good too. And if they don't specify, you're okay to do either one. But stick with radians most of the way. 0. There you go. Hey, there are those solutions for when you're ready. Go back to looking at your faces. Hopefully that went okay. I know number 7 is a little bit up in the glaries. Pi over 6 and 11 pi over 6 is what I got there. Take pictures, put them on canvas for us. Check them out later. I'll upload those pictures after 4th so that I'm not spilling the beans too early for period 4 to get their work done. So around 11:15 or so, I will have those pictures up. How'd you do? Did you do okay? You feeling like you've got a pretty good sense of what's going on here? Tell me, is this old news? Did you do both evaluating trig functions and evaluating inverse trig last year? Yeah, okay, cool. Good, I'm glad we get to do new stuff then. What about 2 years ago in geometry? Did you do any unit circle at all in geometry, or was that just basic like SOHCAHTOA, right triangle, Pythagorean theorem kind of trig? Okay, cool. Yay, new stuff. I'm so excited. All right, awesome. You guys are good? If you're done with these 1, 2, 3, 4, 5, 6, 7, 8, I'm happy. A couple minutes early, yay. And I will see you back here tomorrow for just one last little trig thing. Remember, drop a nomination in for the Apple Awards if you feel like there's somebody in this school that is deserving of that. And if you have any feedback from me personally, I'd love to hear that right at the bottom of today's announcement. Anonymous if you'd like, or if you want to attach your name to it so I can help you specifically with what it was, that's cool too. Otherwise, just make sure this gets uploaded to Canvas. Okay, make sure you have part 1s, 2, and 3. Just take a picture, throw it up on Canvas so I can give you some credit. Cool. All right. Thanks, everybody. I'll see you again tomorrow.
Thank you.
You're welcome.